regression and Durbin-Watson statistics, yes. So, see what happens. You are able to predict errors. Error is actual minus predicted value, and the square of errors, and then this term minus this term. So, this is the meaning of EI minus 1. So, this minus this is here, this minus this and square, and all these are totaled. Then the formula goes like this. It means this upon this, and the value is 3.005. So it's a simple mathematical calculation which you can do. Now, important thing is this, that after having Durbin-Watson statistics, how you will interpret it. That is more important, because this your SPSS output will give Durbin-Watson statistics. Output will be shown here. Here. 3.005. I have shown you the mathematical calculation that how 3.005 is achieved, alright, for your better understanding. But the real thing is how you will correlate, or how you will explain or decode. Now, you need to imagine a scale 0 to 4 in your copy, right, and at the middle you need to put 2. If the scale is 0 to 4, middle is going to be 2, and you need to find two values, DL and DU. L stands for lower, U stands for upper. And this DL and DU, from where you will find? You will find from table. Which table? Every statistics book is having so many tables at the end. Then there will be a table. The name of the table will be Durbin-Watson statistics. And in that table, for a given sample size, in this case it was 12, only 12 data points were there. For a sample size of 12 and for level of significance of 0.5, means 5%, you will get two values which are upper value and lower value. And these values were 1.08 and 1.36. And this 1.08 and 1.36 was correspond to 15 as a sample size, because table was having 15 as minimum number, and alpha as 0.01 and predictor as 1, because only advertisement was used in this. When you are able to find these two values, then you need to put these values here. So DL is equal to 1.08, DU is equal to 1.36, 4 minus DU, you need to find out some value here, and then 4 minus DL. Up to here it is clear? Say yes or no, or I will repeat once again, no problem. Should I repeat? Say yes or no. It means what? Yes or no? No. Good. So it's a scale 0 to 4. Center is 2. You have to find out DU and DL from table, and then you have to plug in the values of DU and DL and 4 minus DU and 4 minus DL. So your scale is ready. And now you have to superimpose or fit 3.05 value on this scale. Where it is? I am going to explain you that how you should interpret these segments. Between DU and 4 minus DU means this zone. Between this zone, if your value of Durbin-Watson statistics fall between this, that's why in the literature it is written that it should be around 2. If it is around 2, it will fall somewhere here, and if it is like that, you can assume that there is no autocorrelation. Number 1. Number 2, if it is between this phase, this space and this space, this and this, within this, then you will take the benefit of doubt. And benefit of doubt means that we cannot conclude if Durbin-Watson statistics fall in this zone. If it is between this phase, there is a positive autocorrelation. And if it is in this space, then it is negative autocorrelation. And if it is positive autocorrelation or if it is negative autocorrelation, both are dangerous. And if it happens, then you cannot apply regression modeling. And you will say that there is positive autocorrelation or negative autocorrelation. Now, what is autocorrelation? What is the temperature of Bangalore today? Just guess. 20, 28. What was yesterday's temperature? Guess, just guess. 27. So today is 28, yesterday was 27. Can you apply common sense and say that today's temperature is correlated with yesterday's temperature? Yes or no? This means what? Yes or no? Yes. Yes means this now. So today's temperature is connected with yesterday's temperature. Another example. There is one exchange rate between dollar and rupees. How much it is? Say 66. Yesterday how much it was? Something very close to that. Can you apply common sense and say that today's exchange rate is connected with yesterday's exchange rate? Yes or no? Sensex, our stock market index. Whatever is the value today, whatever was the value yesterday, we can very easily say that today's Sensex value is connected with yesterday's Sensex value, right? These are the examples of autocorrelation. And these are the things, and if this exists, autocorrelation exists, which is verified by this table, then your regression model is invalid. Then you need to adopt some other techniques. Which are some other techniques? Madhu ma'am, are you noting down?
Yes, sir.
Madam?
I'm listening.
Ma'am, if autocorrelation exists, then other techniques have to be used, for which we will design a separate FDP. Because we need to use this model. Can anybody pronounce this? Yes. So we will have this FDP somewhere in month of February 2017. Right? And this also, can anybody pronounce? What it is? So, what my point is, rare cases, very rare cases. But if your data is having autocorrelation and you need to build a predictive model, then you need to build these type of high-tech techniques, which takes more time in understanding these things, which can be handled or addressed separately. Up to here understood? Say yes or no. Good. Now, open your SPSS software, go to the file, there is a file name. What is the name of the file? What is the name of file? No, grades, no. Name of file is? There has to be a SPSS file, na? Demo, yeah. SPSS file. Open that. And there are two variables, sales and advertisement. Good. I don't know, check the folder. What is the name of the file? Ha. Simple underscore linear regression is the name of file. Simple underscore